This lesson is on 10.5, which is going over the surface area of prisms and cylinders. So when we say surface area of a 3D structure, we don't mean what's inside, we mean what's touching the outside, or the air around it, or the surface it's on, or the liquid it's in. So the surface area of a solid is the sum, so addition, of the areas of all its faces. So if we can find the area of each side, we can add them together to get the total surface area. A net is a two-dimensional representation of a solid, and we'll go through that in one of the examples. The lateral faces of a prism are the faces of the prism that are not the base. So in this case, looking at this picture here of a prism that has a square as the bottom, it's these faces. So the four that go around would be the lateral, and the lateral area would be adding up all of those around. And this would be our base. The top and the bottom are our base. Sorry, that's not writing very well. If we have a cylinder, the lateral of the cylinder is this curved surface going around. We still have the base is the circle at the top and the bottom, and the lateral area of a cylinder is this going around. Most of the time you'll be asked to find the total surface area. However, sometimes they'll ask you to find just the lateral area, so not counting the base. So first problem is using a net to find surface area. So if you had a storage chest that has the shape of a rectangular prism, the net represents the storage chest. So in this case, we're going to use the net to find the surface area of the storage chest. So if we had our shape here, and I've added some labels to it, but basically we had a chest that has a length of 4, a depth of 3, and then this height of 3. So in this case, I always start by drawing the base. And the base is 4 by 3. It's up to you if you want to label the inside of each rectangle or square. That's perfectly fine. So if you wanted to say inside here, this is a 4 by 3, that's fine too. Then I pretend as if this is folding outward. So I take this face 1, I'm calling it here, and the back face 2. They're the same, and they're both also 4 by 3. So then I fold them forward and have 3 by 4 and another 3 by 4 in the back. Then I take the sides and fold them out. So these are 3 by 3. So 3 by 3 and 3 by 3. And then I need to remember to add the top on. It doesn't matter which side you add it to, whether you add it here or to the left, but the top is 4 by 3. Once you have this drawn out, it's really easy now. If we find the area of each of these boxes, then we know the total surface area. So the top and the bottom are 3 by 4, which are 12 each, but there's 2, so 24 total. The sides are both 3 by 3, so they're 9 each, or 18 total. And then the faces, front and back, are 3 by 4, which is 12 each, so 24 total. So we can add 24 plus 18 plus 24 to get the total surface area of 66 feet squared. We'll try these in class together, but sometimes these are easier to draw on graph paper, so you might want to give that a try, and you can always tape an example into your notebook. Another way of finding the surface area of a prism without drawing a net is to memorize this equation. So if we had a surface area of S of a prism is twice the sum of the base area B and the product of the base perimeter, the height. Basically what this means is if we say our bottom area 2 times our base, which is 6 times 4 in this case, plus the perimeter of this base times the height. So we're taking the distance around, which is going to give us this measurement, times the height will also give us that surface area. So this is a way of doing it without having to draw it out and figure it all out. So in this case, we can say, using this equation, that 2 times the base, which is 6 times 4, plus 2 times 6 plus 2 times 4, because we have two sides with a length of 4 and two sides of a length of 6, times 10, which is the height, equals 148 square units. So what I'd like you to do is let's go through another example, and we'll do these in class if you're not sure. But basically, we're using this equation, and this is what's important to remember. If you forget this, we can always figure it out by doing the net as well. Using a formula to find surface area. So the bases of a prism are right triangles now. So now we have this situation. What's tricky here is it's not always what's on the bottom is the base. It's either a rectangle, like here, but sometimes it's a triangle. And in this case, this bottom triangle is what our base is. And they're right triangles. So the equation for when you have a triangle is the same. But remember, when we're finding the base of a triangle, or the area of the base, it's different than when it's a rectangle. So instead, it's base times height times 1/2. So we have 2 of those sides, 2 times the base, which is 1/2 times 5 times 12, plus the perimeter, which is 5 plus 12 plus 13, times 20. So this becomes our height. So then we can simplify that and get 660 inches. What I would do is I would mark on here that this is my base, and the area of my base is 5 times 12 times 1/2, and this is my height, and I would label this long edge as 13, just so I remember, because I know these two are the same. And the third example here is, what if we have a cylinder which has this curved edge? Well, what's really neat about a cylinder is we can find the area of the circles. You know how to do that for the top and bottom. And when you're doing a cylinder, you can imagine a toilet paper roll. When you unravel and take a layer off the toilet paper roll and roll it out, it becomes a rectangle. Well, that's the same thing here. So the area of this lateral surface is the height times the circumference of the circle. So here you can see we have 2 times the base, which are the circles here, plus the circumference times the height. And we can write that out instead using what we know we have to plug in for circles. So 2 pi r squared, that gives us the area of the circles, and we multiplied it by 2 because there's a top and bottom, plus 2 times pi r h. So 2 pi r gives us the circumference, and h gives us the height. So now we can substitute what we know. So 2 pi times 4 squared, plus 2 pi times r, which is 4, times the height, which is 10, gives us approximately 352 square units. So what I'd like you to do is give the following 2 problems a try tonight. You can do it either using the net, or I suggest trying these equations and making sure you understand them to find the surface area of this prism and the surface area of this cylinder here. And bring these with you to class tomorrow. This is what we'll start off reviewing when you get here. That's all for tonight.